Hello, everyone. Today we're going over the properties of squares. So this is 5.9. A square is a parallelogram with 4 congruent sides and 4 congruent angles. Therefore, it's a regular parallelogram or a regular quadrilateral. A square is both a rectangle and a rhombus. Therefore, all the properties of parallelograms, rectangles, and rhombi apply to squares. So if we look at it, it has 4 right angles. All sides are congruent. The diagonals are congruent. Diagonals bisect each other. And diagonals are perpendicular. So these properties are important to help us solve these problems. So MNPQ is a square. So if PNQ is 3x plus 15, so PNQ, 3x plus 15, solve for x. Well, so I forgot to say a property up here, which is the diagonals bisect angles. So if the diagonals bisect the angles, therefore this side is also 3x plus 15. And these two angles together make a right angle. So 3x plus 15 plus 3x plus 15 equals 90. Combine like terms, that's 6x plus 30 equals 90. Subtract 30, 6x equals 60. So x equals 10. So for number 2, MQ equals 5. Find PM. So PM is our diagonal. So when we're looking at our diagonal here, we know that if we take our diagonal and 2 sides, we create a right triangle because all the angles are right. And we also know that the 2 sides are equal. So if MQ equals 5, PQ equals 5. So I'm going to do the Pythagorean theorem where MP is our hypotenuse, so that's C. So for number 2, I'm going to do A squared plus B squared equals C squared. So I'm going to do 5 squared plus 5 squared equals C squared. So that's 25 plus 25 equals C squared. So 50 equals C squared. Take square root of both sides, and C rounded to their nearest tenth is 7.1. For the last problem on this example, they tell me that PA, which I'm making red here, is 4x plus 5, and AQ, which I'm going to make green, is 2x plus 17. Well, I know that in a square, because it's a rhombus, that my diagonals cut each other in half and they're equal. So that means PA is equal to AQ. So I'm going to do 4x plus 5 equals 2x plus 17. Solve for x by subtracting 2x. And I get 2x plus 5 equals 17. Subtract 5. 2x equals 12. Divide by 2. X equals 6. Now, if x equals 6, that means AQ equals 6. Or AQ does not equal 6. AQ equals 2 times 6 plus 17, which is 29. NQ is twice as long as 29. So that means NQ is 2 times 29, which is 58. Find the length of NM. So if we look at this again, this time we're going to look at the fact that I have a different right triangle. So I'm looking for NM, which is part of this purple right triangle. But we know again that these two parts are equal, and they both equal 29 because all our little parts inside are equal. So my Pythagorean theorem is going to be 29 squared plus 29 squared equals x squared. So I do that on my calculator. 29 squared is 841 plus 841 equals x squared. 1682 equals x squared. I then take square root of 1682 and round to the nearest tenth. So it's 41.0 equals x. So now, properties of rhombus, rhombi, and squares. A rhombus, I want to prove that it's a parallelogram first, and then show that two sides that are next to each other are congruent. So that would be 4 distance formulas, or show that the diagonals are perpendicular. To prove it's a square, I can prove it's a parallelogram first, and I can show it's a rectangle where the sides next to each other are equal, and I can prove that it's a rhombus with a right angle. So, prove it's a parallelogram. So I want to prove this is a parallelogram. So to prove this is a parallelogram, I can show that my slopes are all the same, or my opposite slopes are equal. So I do y2 minus y1 over x2 minus x1. And I need to do all 4 sides. So AB, I'm going to do -3 minus 1 over -3 minus 1, which is -4 over -4, so it's 1. I'm then going to do the same thing for CD. So CD, I do -3 minus -7 over 5 minus 1. That gives me 4 over 4, which also equals 1. So that means AB is parallel to CD because they have the same slopes. I then can do the same thing to AD. So AD, I'm going to do -3 minus -7 over -3 minus 1. So that's 4 over -4. So that's -1. And then BC, I do 1 minus -3 over 1 minus 5. So that's 4 over -4. That's also -1. So that means AD is parallel to BC. So ABCD is a parallelogram, opposite sides parallel. So to show number 1 is a rhombus, what I'm going to do is I want to do 4 distance formulas, because if I show all 4 sides are equal, it's a rhombus. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So I can plot it first. -2, -1 is A. B is 0, 2. C is 2, -1. And D is 0, -4. So I'm going to find the length of all 4 sides. So I'm going to do AB. So when I'm doing this, A would be x1, y1, and B is x2, y2. So I do the x-coordinate of A, -2, minus the x-coordinate of B, which is 0, squared, plus the y-coordinate of A, -1, minus the y-coordinate of B, 2, squared. And I do that on my calculator. And I got 3.6 60555125. So I want you to pause and find the other three sides' lengths. So when I found all the lengths, they're all equal the same. Therefore, ABCD is a rhombus. Okay, we will start class tomorrow by doing number 2's, showing it's a rectangle and a square.